We're asked to find this limit, and you might notice that this limit looks kind of familiar. It looks a little bit like the definition of a derivative that we had in a previous section. You'll notice that we have two terms in the numerator, we have just an h in the denominator, and this first term even has something plus h in it. So there are quite a lot of similarities between the given limit and our definition of a derivative. Notice though that the function that we're given in this limit is a sine function. So what if we rewrote this definition of a derivative using f of x is sine of x? Well, just replacing all of our f of x's with sine of x, this is what our definition of a derivative looks like. Well, let's just stop for a moment and admire what we just did. We just came up with a limit that represents the derivative of sine of x, but it's still not the limit that we're given to evaluate in this problem. Well, is there anything else that we can do to make our definition of a derivative look more like the problem that's given? Well, it looks to me like instead of x in our definition of a derivative, at least right here they're using pi over 4. So let's replace x with pi over 4 and see what we get. Well, hey, now that looks a lot more like the problem that we're given. The only difference is here we have a sine of pi over 4 and here we have a square root of 2 over 2. But hey, the sine of pi over 4 is the square root of 2 over 2. So what that means is this limit represents the derivative of sine of x, evaluated then at x equals pi over 4. If we wanted to, we could have written that as the sine of x prime, then evaluated at x equals pi over 4. Either way you do it, you take a derivative of sine of x first, that's cosine of x. Then you plug in x equals pi over 4, that leaves us with cosine of pi over 4. And the final answer for the limit of this problem is just cosine of pi over 4, which is the square root of 2 over 2. And that is actually it for that problem. We're finished. So I guess I'll see you next time in the next calculus problem of the day.